Hello. So today I have a video on this setup, which is a value randomizer. You can't really do this easily in game for any number or for a variable range. So there isn't a trigger that will just do this for you. So you have to do a bit of a more complicated setup. You can do a simpler one, but this one is a bit more unique, or not unique. There's quite a bit of code that went into how this whole thing works. I'll get into it in a bit. The only thing I'll mention is you do not need all of this. This is literally just 10 copies of the same trigger setup. You only need this one. The reason there's 10, I'll get into that in a bit, but it's related to the spawn limit. Triggers have a spawn limit, and this is a way of getting around that. Anyway, let me just showcase this for a bit. So I have two triggers here. They'll choose one value at random, either for a timer or for a counter. I can control what the maximum value is here, as well as the minimum. So I can just choose one between the new minimum and the maximum. Same for here. It will also work if it's like the range, if it's like, it doesn't matter if this one is the minimum or the maximum. It will work either way for both of them. Now, to get into the how this works is both of them need to have like a random integer number at first. That will be converted to, normalized to this minimum to maximum range. And to get that number, the quickest way, not the most optimal way, there will need to be an analysis on what would be the best way to, in terms of lag, to do this. I don't know if advanced random or random is the best choice here, but I'll go with this for now, and I'll update the version that's in the game if I figure out which one is more optimal. But for now, this is the most understandable. So, what's this whole thing of triggers? Basically, if I go into each one of them, this picks at random whether to add 1 to this counter here. This is going to be our randomized number. It's going to be a randomized number between 0 and this number here. So we're going to have a randomized number between 0 and the maximum integer number. And to get that, the way I've decided to go is so by randomizing each bit of the number. So this value sets the rightmost bit to 1 or to 0, or just leaves it 0. This one shifts the whole number, multiplies the whole number by 2, which shifts the whole number, which shifts the number to the left. So if I were to do this in binary, so this is in binary, in mind. So I add 1, then I bit shift it, and I can either add 1 or keep it 0, and I bit shift again, do the same with a 1 or 0, bit shift, and so on until I get 31 bits at the end, which in the decimal representation, in the number base 10, no decimal, base 10 representation, going to be this number at the highest. So this, both 0 and this are included the range. Now, how this value is used by the timer and the counter afterwards differs, but I'll go into the timer first because it's simpler. First, I calculate the range. So the difference between the maximum and the minimum value. Then in the next one, to take advantage of the double precision of the operation, I try to do as many operations in the same time. Here I multiply, and also to avoid an issue with timers. So timers have a bit of an issue, is that they are limited to 99999, to this number at the most and this number at the highest. It actually is not that timers are limited, it's just that operations with item edit that are assigned to a timer are limited between these two numbers. They are not for an item. And to get into another difference over why I used item edits here instead of pickups, because pickups have if you use multiplication, their precision for this operation is float. They have single precision, but item edits have double precision. So for the pickups at very high numbers, there's going to be a visible difference between the output, so the multiplication, and what the operation and what the actual result is. But for this, it's far less likely that it will be for the integer range. So it's not going to happen for the integers as often. Hopefully, never at all. Now, to get back to this, here I multiply the range by our randomly chosen number between 0 and 2 billion, and I divide it by a different number. This one, 238, is the maximum number, is this. That's been saved already in that counter. So I divide our number by that number, and I assign it to the working value. Then at the end, so here I get a value that's randomized between 0 and our range. And to get a number between minimum and maximum, I add the minimum value to the range, so it's now randomized between minimum and maximum. To get back to the maximum value counter in a bit, the initialization is done here. So this is initializing this value of the maximum counter. I'll get into why it's like this right now. So for item edit operations, there's two different results. You have a very high number. If you have a very high number that's going well above this 2 billion range, how it's assigned differs between PC and mobile. For the positive case, on PC, it's going to be negative 2 billion. So it's going to be the smallest integer number. But on PC, it's going to be the highest one. Sorry, on the mobile, it's going to be the highest one. This is not the case for the negative. So you have a discrepancy between this PC and mobile for this particular operation. So you might have a bug that if you, for example, if you had like this on mobile, on PC, the result will just be negative, and your random value might instead just be, if I were to assign this 238 here, I'll show you what's going to happen right now. And I'll move this. So this will choose the random 01. If I do this, it's going to be negative now. So it's something you should ideally avoid. And that's why, because for PC and mobile, the negative case is the same. I'm using this very small, so very high negative number will be like the minimum integer that you can hold in the int32. All items have int32 in the game. Okay. Now, so I have the lowest one, but I want the highest. Now, if you know about how integers work, if you add 1 to this integer, which is the maximum one, it will overflow into the highest -1 or the smallest integer number, which is this. But if you want the other way around, then all we have to do is decrease this number by 1, which we do here. And it has to be done in a pickup because the operation in the item edit are doubles. And if you decrease it by this high number by -1, it's just going to be a negative number again. It's not going to overflow. So you have to do with a pickup here to get the overflow and to get the proper positive value for the counter. Then this simply initializes the maximum value for one for both timers and counters. Now, time to do the counter case. The counter case is a bit more interesting. It doesn't need this counter value, so we can just delete all of this for now. It still randomizes the value between 0 and 2 billion, but how it gets the random value between minus and maximum differs a bit. So, first thing first, we get the range as an integer range between the minimum and the maximum. Then we increase this range by 1. So, because we want both the minimum and the maximum value included in the range, like if I had 0 and 1 for minimum and max, then max 1 minus 0 is just 1. But we have two numbers in this range, so we have to increase the range by 1. That's why there's a second one here. Can't do this all into one operation because it's a multiplier here. So a separate trigger is needed. In this case, here I do the following operation. What's going on here is, in order to get our random value between the 0 and the range, sorry, and the maximum value that can be in the range, we are going to need the reminder of that, or we are going to need to do the modulo operation on the range, sorry, on our very high random number. So, like this. Alright, so what we want is we want to remind what remains if we divide this very high random number to the difference between our minimum and maximum plus 1, which is done in 2 steps. First step, we have to sorry, my throat hurts a bit. Okay. Alright, so first time we do the following operation. First, we divide the high random number by our range. So we get, let's say our high number is 10 in this case, and our range is 3. So we are randomizing between, I don't know, 0 and 2. By dividing, we'll get something like 3.333. And with flooring, we get the integer, just the whole number 3. Now, to get the reminder from the operation, We then multiply this again by the range by 3. So in total we'll get 9. And to get the remainder, we'll subtract 9 from 10 and we'll get 1, which is our remainder. And this is done in two operations. Here we get the highest number that fits. Sorry, we get like the highest multiple of the range that's lower than our random number. And here we get the remainder of the operation, of the division operation. Now, next, so we did get a random number between 0 and 2, because the remainder for 3 can be 0, 1, and 2. Now, there is one issue. This remainder is always going to be positive. But if our minimum number is higher than our maximum number, then you will need to subtract from the minimum. So we now have to determine what the sign of the number is. Like what if we are working with a minimum that's higher than the maximum, or if it's the other way around. Alright, so here we do the whole thing with the operation what we did at the start. But we have this setup that basically takes the range, then divides it by the absolute value of the range again. So we get the sign, like whether the maximum is higher than the minimum. Now, if the difference is 0, then it will just be 0. The result will be 0. So the result for these two triggers here is going to be either 1 if the maximum is higher than the minimum, 0 if they are equal, or -1 if the minimum is higher than the maximum. And taking our range value from earlier in here, we multiply this by the sign. Now, if it's multiplied by 0, that's fine, because if it's 0, then we just choose from one number, which is going to be, of course, either the minimum or the maximum, which are identical. Because we add the minimum back here anyway, it's fine if it's multiplied by 0. So here, if it's like positive, it will just be 1. If it's negative, it will just decrease from the minimum instead of adding to the minimum. So this basically just fixes the case for the min being higher than maximum. That's what these two figures here are for. Well, 4 of them. So 4 of these just to have this be the other way around. Now, why did I not use an item comp in this case, or an instant count? Well, that's because of the spawn limit. Now, if you just want a random value, you can ignore this whole thing here, and you can just put your instant count or item comp and figure out whether these two, which one is higher, and then you can just add 1 or something, or just multiply by whatever you want here. But because I want to be able to spawn this as many times as you want per tick, I'll get into the whole spawn limit just now. I think it's also time to explain what the sequence here does. So, the spawn limit basically is a spawn trigger can only spawn the same group. So, a group as in like one group ID. once per tick. Technically it's twice, but the case for that is a bit, it's once per spawns, like if you have spawns from a delay, spawn delay, and once for everything else. Because there's probably 2 resets of the spawn limit per tick by whatever reason. There's uses for that, they are just very niche. So in practice, it's mostly just one activation per tick per remap. So if you are using remaps, then the spawn limit is going to be independent for your remaps. Now, this independence depends on your highest or your first spawn remap that spawns all of these, that spawns your trigger setup. So if you have a remap setup, remap spawn like this, that spawns a bunch of other spawn remaps here. The limit is not going to depend on each one individually. Sorry, yeah, it's going to depend on this one. So if you have like remaps, the limit depends on each individual spawn or each individual remap. And how that is done by remap ID. I have a video on a bug that involves that. This will need a more comprehensive explanation in an advanced remapping setup, remapping guide. But for now, you just have to keep in mind that whatever the remap spawn, they are independent as long as they isn't a parent. That's sorry, like a parent remap that just spawns all of them. And for this particular case where there's one that just spawns multiple of the same thing, is what this sequence is for. So what does this do? It cycles through all of these copies of the item randomizer, which, as you can see, these are the only spawns the whole setup in order to get around the spawn limit of once per group, per tick, per remap limit. So we are cycling through 10 of them. So per unique remap, we can just spawn 10 of these per tick. You can add more. You can just add 20. You can add even more. This page is technically not limited. You can go way above what you see here. For some reason, there isn't a limit to how many you can have here. So what this setup does is basically every time you activate this, you'll go to the next spawn setup, we'll use the next set of spawns, and the next one, and the next one, and so on. And I'm also using unique remap. Well, this is important because this sequence is going to be unique per each remap you see here. So it's going to be like, it's not the same set of remaps. So, for example, if I'm using like 999, I don't know, 990, even if these have the same remaps, they are still different remaps. So for each one of these, there's going to be a different sequence for each one. So they are going to be independent. And this is important because the spawn limits are independent per remap. So this also needs to be, the sequence also needs to be independent per remaps in order to not have a random chance of just landing on data triggers that was already spawned that tick for that remap. So that gets around that. And I'm looping through all of them. So this will just repeat continuously every time you activate it. Alright, I explained this. Okay, so because these triggers, they are all spawning the same group here, I do need to do this whole thing with advanced sequence to loop through them because otherwise they'll just activate once per tick, and the next time they activate they'll just not add any number here, so it will just result as 0, always result 0, pretty much like this. So this is somewhat necessary. Now if you don't care about the spawn limit, just use one of these. It's enough. You can replace it. You can replace this one with this whole thing. Now why is this shared by both the timer and the counter? Is because both of these need to use the same sequence. In case you are, they cannot be separate unless you have like a separate set of triggers like this also. And you also can't just make this spawn this sequence, because this itself will get spawn limited. So the sequence has to be spawned by, in order to, for nothing to get spawn limited. And that's also why there isn't any other spawn here. I do the operation with like determining which one is higher with minimum and maximum just by using items. There's also a component with how laggy it is. Like in some cases, like in most cases, if you can determine, but if you can calculate something with items instead of item comps, I recommend doing with items. They have better performance than item comps. But if it's more convenient with item comps, use the item comp. It only matters if you really just spam a lot of these things. Like if you're working with thousands of spawns per second, that's where it's relevant. But other than that, you can use, you have got quite a lot of freedom over what you can use. Okay, that's almost 30 minutes. I think I'll end it here. There is more to go over what applications you have for value randomizer, besides just randomizing the value. I'll get through that probably tomorrow. I'll just see when I can upload the video for the advanced random, custom advanced random. I'll get through that tomorrow. Alright. Thank you. I hope this has been interesting enough. I'll see you later.